Optimization is finding the best way to solve a problem when given constraints on how you do such a thing. And without the constraints, there would be no optimal solution. Regardless of purpose, optimization is used to save time, money, and resources, making the most of what you have. There are three ways to optimize: by hand, by classical computer, and by quantum computer. The first way you can solve an optimization problem by hand involves the following steps. So in this problem, the one we did before, it's finding the greatest area a rectangle could have with a perimeter of 6. So the first step is writing down both your equations. You've got your constraint equation, which is your perimeter, and then you've got your area equation, which is what you're trying to optimize. Now in this case, we already know that the perimeter is 6 feet, so we just put 6 here and we solve that. And the idea here is to solve it for one variable. In this case, we could say b is equal to 3 minus h. And then once you get that for your constraint equation, you can plug that back into your optimization equation, and the equation you get from that will be an equation where its maximum value will also be the maximum area in the problem, because it has a constraint. Solving optimization problems by hand is a surefire way to get the answer if the problems are simple. However, when they get more difficult, it becomes necessary to use a classical computer instead. Classical computers solve optimization problems by systematically plugging in every possible outcome to see which one is the best. For example, GPS works by calculating the time it takes to go from point A to point B on multiple routes, giving you the one that takes the shortest amount of time. However, there are some problems too difficult for a classical computer to solve. For these types of problems, we're going to need something called a quantum computer. Quantum computers work by plugging in every possible outcome and testing to see where the error is, thus finding the best possible answer without having to try each individual outcome.
For example, imagine that you need to drop a marble in an extremely tiny crevice, but you don't know where that tiny crevice is. While a classical computer would try all of the x values to see which one works, similar to how GPS functions, a quantum computer would drop an infinite amount of marbles and see on which x value did a marble not hit the ground.
There are many ways to optimize. And in a world where resources are so finite, making the most of what you have is all the more important. As our computers become smarter and technology more innovative, we will be able to solve far more complex systems and maximize time, energy, and resources like never before. Thanks for watching.